So now we're going to introduce a concept that seems pretty straightforward, but in all honesty, at this level, you probably won't use it too much. In the grade 11 and the grade 12 for sure, you're definitely going to apply it a little bit more. But at this level, this stage of the game, it really only has a few key uses. So let's take a loop at this. This is something called nesting, and you know what nesting is. We've already discussed it before. It's when we have one control structure inside of another control structure. So an if statement inside of an if statement, a switch inside of an if inside of a switch. But this also applies to loops, which means I can have a loop inside of a loop. So that could be a for loop inside of a while loop inside of a for loop, a for inside of a for, and so on and so forth. It also means that we could have it also means that we can have selection statements inside of loops as well. So you could have an if statement inside of a loop. We already saw this a number of times in the previous examples. We just didn't put a name on it, but that is still technically nesting. All right. So what do we mean? What are we actually doing here? We're going to look into what it means to actually nest a loop and how does it affect things. The biggest thing it affects is performance on your computer, because what it does is it basically multiplies the amount of work involved for your CPU when you have loops inside of loops. Let's demonstrate this. So looking at this, we have two nested for loops. We have an outer loop which counts rows from 1 up to but not including 4. So row 1, row 2, and row 3. So we have 3 rows. Inside of that, we have a single output statement which displays the current row that we're on. So the first time through this loop, row is going to be 1, second time 2, third time 3. But right below that, we have another for loop. And this one is looking at columns. And again, column 1, 2, and 3 because it doesn't go to 4. So we have 3 rows and 3 columns. Imagine a grid that showed this. I'm going to draw a picture for you here. See if I can get my, oops. Ignore that. You saw nothing. So imagine that I have a grid. Something like a tic-tac-toe board, for example. And this thing has 3 rows and 3 columns. In this case, we have row 1, row 2, and row 3. Column 1, column 2, and column 3. And what this code is saying is it says, and the outer loop is saying, look at every single row. I'm currently on row 1. Now it comes in, it says, now look at column 1. So that means we're looking right here. Row 1, column 1. But we're still in this inner for loop. So it says, now look at column 2. So we're over here. It says, keep going. Now we're at column 3. We're right there. The inner loop is now done. So it comes out, and now it displays that we just finished that row. Comes back up and goes to the next row now. So we just left this row, and now we're pointing at this row here, row 2. Now it comes in, and it looks at column 1, and then column 2, and then column 3. And it goes down and comes back up and does the third row. And looks at column 1, column 2, and column 3. So basically it went through in this order. Why does that matter? Well, think about it like this. We had one outer loop which maintained the rows. And for every one iteration of the outer loop, we did that inner loop 3 times. So now think about this for a second. How many times are we going to see this statement right here appear on the screen? How many times in total is that statement going to appear on the screen? Well, it's going to appear 3 times. Once for each row. So we're going to see this 3 times. It's the same thing goes down here at this bottom one. We're going to see that one 3 times as well. But how many times are we going to see this one? How many times does that one actually show up on the screen? Well, for every row, it completely executes all 3 iterations. So that means how many rows are there? There are 3 rows. And for every, and then there's 3 columns. So 3 rows times 3 columns, we're going to see this statement 9 times. So what we've done is we've multiplied the number of iterations that this middle one is actually going to execute. So that's what happens when you have loops inside of loops. The number of times the code inset all the way is multiplied by the number of iterations. So this one iterates 3 times. This one iterates 3 times. So we get 3 times 3, which gives us 9 iterations. Imagine if you had another for loop inside of here. Then it'd be 3 times 3 times however many iterations this loop was. That's a crazy amount of work. So we have to be very conscious of this when we're looking at our code. Now, what's the logical goal here? Why would you want to do this? Well, using this structure in this example here allows us to go through every single element of this grid one at a time in a very specific order. For every row, look at each column, 1, 2, 3. Next row, 1, 2, 3. Next row, 1, 2, 3. It allows us to access and potentially analyze this. This would be really perfect if you're making a game like tic-tac-toe. So you could actually analyze all those rows and even the columns and hopefully the diagonals as well. So what would this code actually produce in terms of output? Let me get rid of all this stuff here. Well, this. We see that we got that middle thing appear 9 times. 3 here, and 3 at the bottom. Those starting rows appeared the 3 times that we expected. The ending row appeared the 3 times we expected. So there should be no surprises here. Let's take a look at the next one. Now this does the exact same thing. It goes through 3 rows and 3 columns. But inside, it's actually doing some selection statements. It's saying, well, if we're on column 1, we're going to display that as column A. If we're on column 2, we're going to display it as column B. If we're on column 3, we're going to display it as column C. Why would we do this? Well, imagine you're creating a spreadsheet program like Excel. That would allow you to label all your columns as A, B, C, and your rows as 1, 2, 3, which is exactly how Excel works. So we end up with something a little bit more readable. Instead of 1, 1, 1, 1, 1, 2, 1, 3, 1, we end up with A1, B1, and C1. It's a little bit more user-friendly. So that's why we use nesting. It allows us to go through grids of information. It does allow a few other things as well, depending on what kind of data structures you're working with. Now let's move on into something a little bit more applicable. Here we have a simple loop and a conditional inside it, a selection statement. Well, what's actually happening? Read the comment. If the remainder of dividing number by 5 is 0, then it's evenly divisible. So what is this program doing? It's displaying all of the numbers from -3 all the way up to 32 that are evenly divisible by 5. Well, pause the video for a second. See if you can come up with all the possible numbers that work out for this. Okay. Now, let's see if you got them all. I'll bet you a lot of you missed the very first number, which is 0. 0 is evenly divisible by 5. 0 divided by anything is 0. Well, that means that the remainder is 0, so this if statement would execute. Now, whether 0 is considered a divisor of 5 or not, it's not in reality, but the way this logic is written, that's the way it works. So we have to follow the way the logic goes here, and that's what's actually going to be displayed on the screen here. So going back, summarize, what is nesting? Well, nesting of loops is just having loops inside of loops. And at this point in your programming career, it's not going to be super useful unless you're doing something really interesting for some projects later on in the course. Outside of that, more just understand the fact that whenever you have an inner loop, the amount of iterations that one's going to execute is a multiple of the outer loop multiplied by the inner loop. And that's it for nesting. And that's also it for loops. The next lesson, we're going to go back and we're going to finish off flowcharts.